Hello, it's Science O'Clock and time for you and I to do some science together. Today we're doing acid reactions. We've basically been doing things about acids for a few lessons, few weeks. Now we're bringing it all together with a series of questions that's just going to test whether you remember stuff. Don't worry, I'm going to help you as much as I can. The aim of today is to be able to describe the reactions of acids with different bases. Actually, it's just the reactions of acids. Let's start off though. Can you name 3 acids? Can you then give the formula for those acids? Can you name 3 bases? Can you give the formula for those bases? And what is the basic reaction for an acid and a base? Pause and answer those questions. If you can't answer them, all of them, do 1 or 2. You can give me 1 acid. You can give me 1 base. You can tell me what happens when you put them together. Go on. Pause and answer the question. Unpause when you're done. Have you done so? I knew this was coming, so I'll have the answers on the next slide. But it doesn't want to go to the next slide. Here we go. Right, the acids that you know. You know this acid, sulfuric acid, H2SO4. Do you know this acid, HNO3? And you know this acid, HCl. I'm sure you use those. Some of the other acids, the slightly less common, quite weird ones. Citric acid, COH, CH2, 2COH. That's a beast. Tartaric acid, ethanoic acid. Lots of H's. Strangely, this one has an OH. But bases, good examples of bases. Here we have sodium hydroxide, NaOH. Potassium hydroxide, KOH. And another one, calcium hydroxide. Why is there a little 2 there? But there isn't here. Well, remember, these are group 1. Group 1s have a charge of +1. OH has a charge of -1. +1, -1, easy. +1, -1, easy. But calcium's in group 2. What charge does calcium form as an ion? It forms +2. So we need 2 of these hydroxides to balance out. But the O and the H together make -1. So we put brackets around it, boop, boop, and put a little 2 here. So CaOH, that's really, I've just made it really difficult to see. CaOH 2. Nice. And I mentioned to you before, there are different reactions, and these are a summary. In fact, I think I missed one. I've missed acid and base. Silly sausage. Acid plus base. Salt plus hydrogen. Now, these are the main reactions that you're going to need for the rest of this lesson. Acid plus alkali goes to salt and water. Acid plus metal goes to salt and hydrogen. Acid plus metal oxide goes to salt and water. And acid and metal carbonate goes to salt, carbon dioxide and water. And I think in the next lesson we'll do a little experiment with these ones. But that's just a really good cheat sheet. Write those down in your book. Make sure you do a big box around it. Put little arrows that say important. You're going to need to come back to these quite often. So pause the video and make sure you write those down. Are we done? I will continue then. Oops. Now, we're just going to have lots of questions, but don't be afraid. I'm going to help you with these questions. I'll add some notes. I'll give you answers. There's a lot of information on this page. Let's do it one section at a time. Imagine a new metal, given the symbol X has been discovered. It lies between calcium and magnesium in the activity series. Which one is higher? Calcium is higher, X, and then magnesium. Describe the reaction of excess X with dilute sulfuric acid and give the word and balance simple equations. Interesting. Okay, so basically, acid plus metal goes to salt plus hydrogen. Excellent. So the acid is sulfuric plus X goes to, now what type of salt does sulfuric acid make? So it'll make, what type of salt? Sulfate. So it would be X sulfate plus hydrogen. Excellent. A balanced simple equation, sulfuric acid. What's the formula for sulfuric acid? H2SO4 plus X goes to XSO4 plus H2. Easy. Explain how you cannot be sure how X will react with cold water. What happens to calcium if you put it in cold water? If you're not sure, check online. What happens to magnesium when you put it in water? If you're not sure, check online. Do you know what? I'll just tell you. Magnesium, you put it in water, cold water, nothing happens. Calcium, when you put it in water, it bubbles very, very vigorously and produces a lot of heat. If X is between the two, can you predict what it'll do? I'll leave that one to you. X is added to a solution of copper nitrate. Explain what you would expect to see happen. And can you do a balanced equation with state symbols? If you could just do the word equation, that's fine. But if you could do the balanced ones, that's even better. So, copper nitrate. Oh, where's the thing gone? There it is. Copper nitrate. So CuNO3. Okay, that's 2 plus nitrate is, gosh, 2 of those. Copper nitrate plus X. Now, this is a displacement reaction. Is X more reactive than copper? If it is, what's it going to do? It's going to do, so it's more reactive because over here, copper is going to be way down here. Can you work out what happens? I haven't taught you how to do this yet. Ignore that. Another new metal does not react with water, but there is a slight reaction with warm dilute acid. Where would you place Y in the reactivity series? Explain what you'd expect to happen. Basically, would you put Y here? Here? Here. Any of these places? Place, replace. What would you do? Some bits I've given you the answers, some bits I'd like you to work out yourself. Okay. This should be, hopefully, doable. You're going to need your reactivity series. Which substances will react? We've got copper plus copper oxide. If there's a reaction, you tell me what will happen. If there's no reaction, you just write no reaction. For example, here, is iron more reactive than zinc, or is zinc more reactive than iron? This is displacement reaction. If you can't remember what it is, look back in your book. So, 1, 2, 3, 4. Either no reaction, or just write down the name of the reaction. And then, for those of you who are feeling confident, but I bet you could all do it, can you write it down in a formula? You know what the formula for copper is. Cu. You know what the formula for oxygen is. O. You know what the formula for carbon is. C. It's not that hard. Go on, let's do this one. Carbon, copper oxide. Carbon is higher than copper, so it goes to carbon dioxide plus copper. That's the word equation. The symbol, carbon dioxide is CO2, copper is Cu. Let's see if we can balance it. We've got one C there, but we've got one there. We've got one Cu, we've got one C, we've got one O, we've got two. So I'm going to need two CuO, two of those, and it's all balanced. If you can do that for all more than, even better. Oh, symbols. What is carbon dioxide? It's a gas. Copper. It's a solid. Copper oxide. Solid. Solid. Easy peasy. Reaction between aluminium powder and iron oxide is used in the railway industry. Write the word equation and then can you work out the balanced symbol equation. What do you call this reaction? Okay, so iron, Fe, iron 3 oxide, so it has a charge of +3. Oxygen has a charge of -2 when we're making ions. How do you balance something like 3 and 2? That's trickier. If you've got 3 of something and 2 of something, you can't have, if you have 2 of these, that's 4, that doesn't work. If you've got some odd numbers, you multiply them by each other's charge. So if we have Fe2, O3, 3 here, 3 oxygens, 3 times -2 is -6. 2, oh no, 2 times +3 is +6. So 2. So Fe2O3 is the formula for iron oxide plus aluminium powder, Al. Is it a displacement reaction? Is aluminium more reactive? It is. So then you're going to form aluminium oxide. But the formula for aluminium is +3, oxygen's O2. Can you work out the formula for aluminium oxide? You can do this. And what do you call this reaction? We talked about this. Pause. Try and finish that off, please. If you're not sure, you can look it up online. But I'm online. Just answer it. Are we done? Splendid. Lead is often found in the ore called galena, which contains lead sulfide, PBS. Before reduction with carbon, the lead sulfide must be converted into lead oxide, PbO, by roasting the ore. The reaction with oxygen from the air also produces sulfur dioxide gas. Write a word equation for the roasting of lead oxide. Okay, let's just go through it piece by piece. Lead is often found in the ore, PbS. Before reduction with carbon, the lead must be converted into lead oxide by roasting the ore. The reaction of oxygen from the air also produces sulfur dioxide gas. So here is now required oxygen. So plus O2. So lead oxide plus oxygen. I was going to do it in words, wasn't I? Sorry, lead sulfide plus oxygen, arrow, and then it turns into lead oxide and sulfur dioxide gas. Dioxide gas. That's it. So I've given you the formula for this, formula for this. They've given you the formula for this. Work it out, and I bet you can work out the formula for sulfur dioxide. I bet you know what the formula for carbon dioxide is. Can you convert it to sulfur dioxide? Yes, you can. So write a word equation. I've just done that. Can you do a simple equation? If you're feeling brave, you could try and balance it as well. Go on. Lead oxide is reduced by heating with carbon. Write a balanced simple equation for this reaction, assuming CO2 is reduced. So, PbO plus C. What does it turn into? Can you see if you can balance it? Can you see if you can just write it out? Do it as words first. PbO plus C goes to, is carbon more reactive than lead? Is it going to steal the oxygen? What does it turn into when it steals the oxygen? Nothing's there. Do it as a word equation, you doofus. Number 5. Nickel 2 sulfate crystals can be made from an insoluble oxide base and sulfuric acid. Name the insoluble base that can be used to make the nickel sulfate. So, if we've got, so something makes nickel sulfate, and we've got sulfuric acid. So sulfuric acid makes a sulfate. And it's an oxide base. So over here, well, what are we missing on this side of the equation? We're missing nickel. But what do we know about the thing on this side of the equation? It has to be an oxide base. So nickel oxide. What type of reaction is this? Are we missing anything? Nickel oxide, sulfuric acid. Oh yeah, what does it produce? Nickel oxide, sulfuric acid. So we've got H2SO4. Yes. What's missing? What's left over? What elements on this side haven't come across to this side yet? What type of reaction is this? And how, once you're finished with this, can you get the nickel sulfate crystals? I just did this in the experiment the other day. And that's it. Oh my goodness, so easy. Maybe I'll write some other clues up and give you some other ways to answer this, but I believe in you. Keep going, answer all the questions. Bye!